Hey everyone, we're going to go ahead and get started. Thanks for joining us for today's webinar. I'm Major Jeremy Dehart. I'm the Assistant Director of Operations here at the Squadron, and this is our summer quarter. We do ask that if you have any comments or questions, that you keep questions maybe asked over the phone or type in. So we'll have someone monitoring. Also, we ask that you please keep phones on mute until the end when you have a question at that time. Your feedback is also very important. Feedback is also important to us. So we do have a different method for providing feedback with this DPS platform. We'll go over that at the very end. We've got a slide to show you where you can download our. We're going to go ahead and do is look at a few updates that we've made to our Squadron webpage. So if you visited us on our page, www.climate.af.mil, you know that we've got a pretty extensive product set. So we're always looking at ways to make these products more discoverable for our users. We've developed this guide that's got linked to on our webpage. It's in PDF form. You can see we've got two different locations that links to the same product. We've developed a quick link down here, a button down toward the bottom of the page. Got it as well up in our menu bar at the top of the page. When you click that link, it'll bring up this home slide, and it's of frequently asked questions to kind of point you to a product that you might be looking for. You don't know exactly what it is that you're questions that could be asked. Ask hourly temperatures, heating direction. At our OCDS2 application as a requested flagship product. So if you click on that OCDS link, that'll take you to a slide. It'll basically take you step by step on how to produce that product. Here you can see the station identifier or the station name. It'll give you an option format that you could have that product produced in. And ultimately, you get the product itself, a tabular display of climate data for that station. Next slide, here's another option for you. You can click on the Advanced Options button. That'll bring up a list of parameters. Say you want to maybe look at the units in terms of Zulu time versus change your thresholds for your that as well, and that button and then generate. That's just an example of one of those products that you could click on. Process. Maybe that's not exactly what you were looking for. Graphical in nature, and you kind of go back to this questions list. Our climogram, it's essentially a graphical representation of our that as well. And again, very similar. It'll take you step by step through the process to generate. Ultimately, there's the product as graphical representation. And we've got this entire listing. This is essentially our entire product suite that's I show. So, not sure what you're looking for. Go ahead and click on those help links from our homepage. Questions. Of course, as always, if you can't figure out exactly what you might need, you can always send a request or a SAR. And then going to this last webinar, we introduced our recent SARs page. We've made a few updates to that page as well and throw some examples products on that page. So we'll talk about that when we get to that section a little bit later in the webinar. So check that page out as well. Update we've made to our page, our web page. Climate slides that we're getting ready to we've added these to our website. So if you on the CMAP button from our homepage, that will take you to that section, and right below where we have our monthly sit rep, we'll also have our global. So we'll update those on a monthly with our sit rep and have those slides. That's it for our product updates. I'm going to go ahead and check Sergeant Beasley, our global state.
Review the state of the climate. Joined us in April, we showed you a few charts displaying the Madden-Julian Oscillation, or MJO, and the El Niño Southern Oscillation, or ENSO, and their teleconnections, recent global temperature and precipitation. Today, we will look at those oscillations again and focus on their phase and effects on the climate. Remember that a teleconnection refers to recurring and persistent large-scale patterns of pressure and circulation anomalies that span the globe. First, we will review the current and forecasted phase of the MJO. Remember, the MJO is an intraseasonal fluctuation affecting primarily the tropical Indian and Pacific Oceans, which is responsible for the majority of short-term weather variability in atmospheric and oceanic parameters. Displayed on the left is the real-time multivariate MJO index, or the RMM diagram. Track and forecast the 8 phases of the MJO. The phase diagram on the left shows the evolution of the MJO over the last 40 days of observation, along with the 15-day ensemble GFS forecast. Dark shading indicates that 90% of the model ensemble members fall in this area. For the first part of June, the MJO had a low amplitude wave. Amplitude then quickly began rising through to July 5th as the MJO positively interacted with El Niño in the tropics. The MJO over the past month has remained very active with at times very high amplitude. Amplitude on July 5th was the highest July value on record dating back to 1981. The diagram on the right is a depiction of the forecasted anomalous outgoing long-wave radiation, or OLR, based on the ensemble GFS forecasted RMM phase over the next 15 days. Blue shades show negative OLR anomalies, which are indicative of enhanced convection. In these areas, you can expect increased convection as compared to the seasonal norm. Yellow and red shades represent positive OLR anomalies, indicative of suppressed convection. In these areas, you can expect a decrease in convection when compared to seasonal norms. The 14th Weather Squadron also uses this information to compile our Pacific Tropical Convective Forecast that is shown here, which is used by RPA pilots in support of Global Hawk Mission planning. The forecast product is updated weekly and can be found on the CMAP webpage. Using information about the MJO, its projected phase, and other model predictions, we are able to get an idea of what to expect for our forecast. We also evaluate the El Niño conditions to determine its effect on our forecast period. MJO is forecasted to remain relatively inactive for the forecast period depicted here. This forecast was based on persistence and El Niño influence. Tropical Pacific Convective Outlook is produced once a week in collaboration with the Climate Prediction Center. We are currently in an El Niño state of the ENSO. There has been a continued increase in sea surface temperatures, enhanced equatorial convection, and increased persistent low-level westerlies. All of these are characteristics of El Niño conditions and are expected to persist over the course of the next few months. This year's El Niño is expected to be one of the strongest in the last 50 years. There is greater than a 90% chance that the El Nino conditions will continue into the Northern Hemisphere autumn, and an 80% chance it will last through the 2015-2016 winter, according to the Climate Prediction Center, or CPC. Looking at the International Research Institute, or IRI, and CPC plume of the model ENSO predictions, we can see that majority of the models are predicting that the sea surface temperatures in the Pacific continue to be at least 0.5 degrees Celsius higher than normal into the beginning of 2016. El Nino conditions typically bring a suppressed Atlantic hurricane season, cooler and wetter conditions in the southeast U.S., warmer conditions in western Canada and Alaska, and wetter conditions in California. Now we will examine how these oscillations impacted global temperature trends over the past month, 31 May to 30 June. There has not been much change in temperature anomalies over the past few months. Eurasia continues to experience above normal temperatures. As noted in our sitrep, Pakistan experienced a deadly heat wave that claimed 800 lives. On June 20th, Karachi International reported record temperatures of 44 degrees Celsius. As typical, during El Nino, both the western United States and western South America experienced warmer than average conditions. Looking at the precipitation trends from the past month, 31 May to 30 June, we will see connections with the phases of the MJO and ENSO in the precipitation anomalies. As previously mentioned in the last webinar, the MJO brought above average precipitation to the Horn of Africa and India. As noted in our sitrep, to the east of India in Bangladesh, above average precipitation brought torrential rainfall, led to localized flooding and embankment failures. MJO brought drier than average conditions to the western U.S. The ENSO brought wetter than average conditions to Mexico, the equatorial Pacific, and western South America, as well as continued drier than average conditions in parts of southern Central America and northern South America. As noted in our sitrep, the water supply for over 20 million people in the city of Sao Paulo is at 15.4% useful volume and 19.9% useful volume and technical reserve. Now that we have reviewed current global conditions, let's look to see what is in store for the future. August, look for continued warmer than average conditions over much of the globe. Expect persistent warmth in Eurasia and above average temperatures off the west coast of South America into the Pacific. Also expect persistent warmth in the northeast Pacific. Precipitation rates will be above average due to El Nino along the equator in the Pacific Ocean. Drier than normal conditions are expected in Central America into northern South America, Indonesia, and India into the Arabian Sea. Drought has improved slightly across the globe from the last webinar. Intense drought has continued in the western U.S., western and northern Canada, and Central America. Pockets of intense drought continue in South America and Africa. Drought in southwestern Russia and Iran has expanded, while drought has continued to intensify in the Korean Peninsula. Drought also continues in Bangladesh and Australia. Now that we have reviewed the current global conditions, let's look at what is in store for the future. Drought conditions into September 2015 are similar to the current conditions. Expect a slight improvement in the western U.S., western and northern Canada. Central America, drought conditions will intensify slightly. Also expect drought intensification in northern South America, equatorial Africa, as well as the western Sahel. Southwest Russia, look for drought conditions to spread slightly. Drought conditions will improve in eastern India into Bangladesh due to the monsoon rains. On the Korean Peninsula, drought is expected to intensify. Due to a strong El Nino, Pacific typhoon season is expected to be very active, and the Atlantic hurricane season to be suppressed. As of now, Pacific tropical storms, typhoons, and are more numerous than during this time in 2014. The amount of typhoons through July 2015 has tripled compared to this time last year. while the amount of super typhoons from the start of typhoon season in July 2015 has doubled. As of halfway through the typhoon season, the number of super typhoons is 80% of normal for an entire season. Peak of the season has not yet occurred. Peak of typhoon season typically occurs in August and September. Expect an increased amount of activity in the Pacific as the year goes on and El Nino gets stronger. You can see on the chart, Atlantic hurricane season has been somewhat suppressed this year compared to the historical averages. While there has been 3 named storms, there have been 0 major hurricanes this season. We will continue to monitor those areas to see how El Nino is influencing cyclone development. Staff Sergeant Brantner will now highlight some of our recent tailored support.
Hello, this is Staff Sergeant Brantner, and today I'll be highlighting some recent SARs. Before I start, I do want to mention that we have updated our recent SARs page. On the front page of our site, simply click on the SARs icon to see SARs which will be updated. On April 25th, 2015, Nepal experienced a 7.8 magnitude earthquake which killed more than 9,000 people and injured over 23,000. Hundreds of thousands of people were also left homeless as entire villages were flattened along with centuries-old buildings. Besides the earthquake, there were numerous aftershocks and avalanches with the risk of landslides. These aftershocks were still being felt into the middle of May. Relief operations expected to take some time. We were asked about the upcoming monsoon season. Leveraging monsoon start and end dates from the Government of Nepal Ministry of Science, Technology and Environment, the SAR team developed an analysis of historical Nepal monsoon onset and end dates by merging their data with El Nino and La Nina periods. First, we found that the monsoon onset was anywhere from 1 week early to 2 weeks later than average during El Nino years. Furthermore, our analysts determined that the average monsoon onset was around June 10th through 12th, while the average monsoon onset during El Nino was June 15th. The chart depicts cumulative precipitation and shows the effects of El Nino and La Nina on precipitation totals. While the median monthly monsoon precipitation is approximately 10 to 15 inches and totals on average between 50 to 60 inches annually, delayed onset typical of El Nino years leads to a decrease in cumulative precipitation. Regardless of any potentially abnormal monsoon conditions, locally heavy monsoon rains still increase the risk of localized flooding and landslides following the recent earthquakes. By leveraging our own ENSO data along with the precipitation data, our analysts were able to provide a better estimate of monsoon precipitation amount. Lastly, a forecaster at the 18th Weather Squadron headquarters in Fort Bragg was looking for climatological data to use in providing staff weather briefings and mission planning to supported units. Rather than simply providing the data, we coordinated all of the mission limiting criteria and automated the production of a stoplight chart for use in briefings, similar to a product already in use at the 18th. By automating the process, we can now create this product for any location in just a few minutes as long as the station has a sufficient amount of data. These are just a few examples of what our climate analysis team can do to provide you with what data you need. An important thing to keep in mind is that we generally can help you better if we have as much information as possible and we know what you're trying to do. If you need to submit a SAR, go to https://www.climate.af.mil and hover over the Request Support tab, then click on Submit Support Request. We look forward to hearing from you. This concludes this quarter's webinar. Please take a moment to provide us your feedback on this webinar as we look forward to incorporating your inputs into future webinars. The form can be downloaded by clicking the arrow found in the lower left-hand corner. At this time, we'd like to open up the floor for any questions or comments.
ahead and ask your questions or make your comments either in the DCO window or over the phone. Okay, well, we'll go ahead and officially end the webinar. We'll stay on the line and have DCO up or DCS up for another 5 minutes or so if anyone else out there has any parting words or questions. To everyone else, thanks for joining us, and stay tuned in the next couple of months for a notice that goes out for our fall webinar. Thanks again.